Hello, Professor Lehman. My name is Billy Sample, and today I will be solving the Video Presentation 1 assignment. Okay, so we're trying to find how far above the surface H must be so that the fluid doesn't get sucked into the slit that's in the problem. So we start out by writing the equation of a stream function. It's for uniform flow and the sink. So that is equal to psi is equal to UR sine of theta minus M over 2 pi theta. We can label that as equation 1. We'll come back to that later. So the next step is to calculate the radial component of the velocity. So that will be VR is equal to 1 over R times the derivative of psi over the d theta. And that is equal to, for that is 1 over R d theta times, in parentheses here, the equation 1, UR sine theta minus M over 2 pi theta. And then we can break that down to 1 over R UR cosine theta. That's what happens when you take the derivative of it. Sine turns to cosine. Then M 2 pi, the theta just goes away. And then that'll give us U cosine theta minus M 2 pi R. And now we have to calculate the tangential component of velocity. By the way, that could be like equation 2 right there. So V theta is equal to a negative derivative psi over dr, which will give us equal to dr times UR sine theta minus M 2 pi theta, and then taking the derivative of that will just give us negative U sine theta minus 0, which is just equal to negative U sine theta. That can be like part 3, equation 3. Can you see that? Sorry, kind of hard to see. But now we keep going. So now we're going to be along the wall. Where V naught is equal to 0. The stagnation point occurs where VR is equal to 0. Sorry, I just forgot about that really. VR is equal to U cosine theta minus M 2 pi R. And then so VR, and this will set VR equal to V theta. Yeah, VR is equal to 0. And then plug that in, and then cosine, or the theta is 0 degrees minus M 2 pi R, and then the cosine of 0 degrees will just turn into 1, so it'll be equal to U minus M 2 pi RS. And then we just solve for the radius. RS is equal to M over 2 pi U, which is equal to 0.2. We multiply the 0.1 value by 2. That's how we get 0.2 on top, and then there's just 2 pi times 4 feet. S, just a flat surface. And then I already had it calculated out, but actually I'll just I found that equals 0.00796 feet. So our stagnation point, stag point is right now is R theta, which is equal to 0.00796 feet, just to know just so we know our units. And then theta is 0 degrees. So at this point, the value of the stream function, this is at this point, psi is 0. So we can go back to equation 1, which 0 is equal to UR sine theta minus M over 2 pi theta. And then we can we put r sine theta on one side, and then M over 2 pi U theta on the other side. And then our sine theta is basically just y, so it's just y is equal to M over 2 pi U theta. And then so the fluid above the stagnation streamline will not be sucked into the slit, and the maximum distance h for the stagnation streamline occurs as theta approaches pi. So now we're at the final stage where h is equal to m pi over 2 pi u, and then that gives us 0.2 feet squared per second over 4 feet per second, which is equal to 0.0250 feet. So our height, h, is equal to 0.0250 feet.